Alright guys, I just got an email from a student that requested an extra example about a couple of the problems on our homework tonight. So I said, what the heck, why not? So here you go. I'm going to give you a couple of examples. The first one is when we're multiplying two radicals. The second one is when we have a radical that has variables inside of it. Okay, so we'll go ahead and look at these two. And really, if you don't have a background in simplifying radicals already, you may need to look at how to simplify just a straight up radical first before you start looking at ones that are a little bit harder like this. But I'll try to work it through as basically as I can so that it'll make it a little bit easier for you. So here's the first one. We have the square root of 5 times the square root of 60. Now, we talked about, actually, at least in my class, that we could take the square root of something, say 4 times 10, and we could split that up into the square root of 4 times the square root of 10. Well, if I can do it that way, why shouldn't I be able to go backwards? That's the whole thing about math, is if you can do it one way, you can do it the opposite way and go back. And so what we're going to do, because I can't take the square root of 5, and I can't take the square root of 60, is we're going to rewrite this as the square root of 5 times 60. Now from this point, you can multiply the 5 times the 60 if you want, but if you remember, once we have that number inside the square root, we need to find the perfect squares. So really what should happen next is I need to take this and factor it out as much as I possibly can. So I'm going to take that 60, and 60 I know is 6 times 10, and 6 is 2 times 3, and 10 is 2 times 5. Now all of those are prime numbers, so I factored as far as I can. So now I'm going to write this as the square root of, now I still have that 5 in front, times, and then I've got a 2, and another 2, and a 3, and a 5. And so I've factored it completely into its prime factorization. Now what I'm looking for are the pairs. I'm looking for the pairs because I know if I take, for example, 2 times 2, that's going to give me 2 squared, which is a perfect square. I can take the square root of that. Okay, so I'm going to go ahead and do that. And so we're going to have the square root of 2 times 2, which is 4. And do I have any other pairs? Why, yes, I have 2 5s. And so 5 times 5 is 25. And then I've got that 3, which is still all by itself, but I've got to include it. So there's the times 3. So this, 4 times 25 times 3, is the same thing as 5 times 2 times 2 times 3 times 5, which is the same thing as 5 times 60, which is the same thing as the square root of 5 times 60 is 300. So these are all the same thing. I'm just writing it in a form that I can take the square root of some of these numbers. So now at this point, I'll take the square root of 4, which is 2. So it's not in the square root anymore. I'll take the square root of 25, which is 5. And I'm still got that 3 there. I can't take the square root of 3, therefore it's going to have to stay by itself. And so 2 times 5 is 10, root 3. That is your simplified radical because I can't simplify the root 3 anymore. All right, let's go ahead and look at this other one. We'll go a little bit faster because this is really the same thing, except now we just got a couple of variables. All right, so let's take that 150. Let's split it up. 15 times 10. Now it doesn't have to be this specific order, but that's what I ended up with. So I'm going to rewrite this now as the square root of 3 times 2 times 5 times 5. Yeah, I switched around the order, but it's multiplication. Multiplication, you're allowed to do that. Now instead of a squared, I'm going to put a times a. I've got 3 b's, and I've got a c. And so now I'm going to go through and look for my pairs. I've got a pair of 5s there. I got a pair of a's here. And then I've got a pair of b's right there. Okay, so I'm going to rewrite this as the square root of 3 times 2 times 25 times a squared times b squared times b times c. All right, now I can take out the things that are squared. So I've got the 25, which is 5. The square root of a squared is a. The square root of b squared is b. And so now I'm left with, because I can't take the square root of 3, So it's left. I can't take the square root of 2, and I can't take the square root of those b's and c's. And so, of course, the 3 times 2 will allow me to have my final answer, which is the square root of 6bc. Nothing else can be square rooted. There's no more perfect square roots, so we are then done. I hope that's helpful to my class and anybody else who might see this. Cheers!